In today's video, we will learn about principle of moments. Principle of moments states that when a body is balanced, the total clockwise moment about a point equals the total anti-clockwise moment about the same point. What is meant by moment of force is nothing but torque. So d1f1 is equal to d2f2. In this case of this lever, for example, here we have fulcrum, that is the joining of this lever, which is at a distance d1 from the first mass and d2 from the second mass. So d1f1 is equal to d2f2 is the principle of moments, or torque 1 is equal to torque 2. Let R be the reaction from the support or the fulcrum. D1 and D2 are the distances from the fulcrum to the forces F1 and F2. Here one of the force is called the load and the other force is called effort. So here we can say in this example over here in this crane, the load is taken on this side. There is an effort balancing force applied over here, and this is the point where the fulcrum is. That is where the attachment is given, is called the fulcrum. In this seesaw, again you can see here, one can be called as a effort and the other can be called as a load, and this is called the fulcrum. Now we will check how is this principle of moments we can establish. Since the lever is a system in mechanical equilibrium, let R be the reaction of the support at the fulcrum. R is directed opposite to the forces, as you can see, F1 and F2. For translational equilibrium, the total force must be equal to 0. So what will we do is we will take this F1 as a negative force. F2 is also a negative force. R is a positive force according to their direction. So what we can write is sigma F is written as minus F1 plus minus F2 plus R is equal to 0. This is the F net. For considering rotational equilibrium, we take the moments about the fulcrum. So that is what is meant by moments about the fulcrum. The total moments or the total torques about the fulcrum is d1 cross minus f1 plus d2 cross minus f2. That should be equal to 0 in case if this is the condition, that is like this crane is standing here. Similarly, there is a balance between the sides, both the sides of the lever. Here the total torque is equal to, how we calculate is minus d1 cross minus f1 plus d2 cross minus f2 equal to 0. Why we are taking minus d1 here is it's a vector distance. So if you take towards the right of this fulcrum positive, the left of the fulcrum distance should be taken as negative. So what is minus d1 cross minus f1 is d1 cross f1 plus this is minus d2 cross f2. Now d1 cross f1 is d1 f1 sine theta, but sine theta over here is 90 degree. The distance d's and the forces are acting in both sides at 90 degree. So it will be d1 f1, just d1 f1 equal to, we can say, d2 f2, or f1 by f2, the ratio f1 divided by f2 is equal to d2 divided by d1. This is known as mechanical advantage of the lever. So what is F1 and F2? I told you F1 is the load if you are taking. F2 should be taken as the effort. So D1 will be the load arm of the lever and D2 will be the effort arm of the lever. So this formula, that is F1 by F2 is equal to D2 by D1, is very important in lever. It decides how much mechanical advantage we get when we use a lever for lifting objects. D1 F1 equal to D2 F2 is known as the principle of moments. If we expand and write it, it is load arm into load is equal to effort arm into effort, because we called F1 as load and D1 as its load arm. Similarly, D2 is the effort and D2 is the effort arm and F2 is the effort.